Today I want to go over solution concentration. So, there are two different ways that chemists often measure solution concentration when they're in the lab. So, I'm going to be going over those two main ways. The first way is something called molarity. So, this is from the mole unit. So, here, when we describe the concentration of a solution, if we're talking about molarity, we get our solute into moles using the molar mass from the periodic table, and then we divide that by the liters of solution. So molarity is abbreviated as capital M, or sometimes it's called molar, and again, it's moles of solute per liters of solution. So let's look at a couple problems with this. So here, we're asked to find the mass of oxalic acid that's required to make 250 milliliters of a 0.0500 molar solution. So like I said, sometimes this is called molar. Just so if you see that, you know what they're talking about. Okay, so we have our equation. Molarity is equal to moles of solute over liters of solution. Okay, so when you're using this equation, you should have two of these things to be able to use this equation. So if you're given grams, for example, and asked to find molarity or asked to find liters, you're going to have to get that into moles. So we have 250 milliliters of our solution. So we need to get this into liters. So 250 milliliters is equal to 0.250 liters. And then we have our molarity. So that goes over here. So we have 0.0500 molar. So instead of writing molar, I'm going to write moles over a liter because capital M is equal to moles over liter. And this is equal to moles, so that's our unknown. So I'm going to put X in the numerator. And then I'm going to put the liters of solution in denominator. And then I'm going to solve for X. So when I do that, I have to cross multiply, the liters cancel out, and I get 0.0125 moles. So now I'm going to have to use my molar mass. And if you guys remember from the mole unit, we have moles here, we have grams over here, we have particles over here. If we're going from grams to moles, remember we're going towards moles, we divide by the molar mass. Going the other way, we multiply by the molar mass. Okay, so here we have moles. So since we're going from moles to grams, we're going to be multiplying by the molar mass. So we have 0.0125 moles over 1. And then we're going to have to calculate our molar mass for oxalic acid. So we have 2 times 1.008 plus 2 times 12.01 plus 4 times 16. And that gives us 90.036 grams of oxalic acid. So if we multiply that by 0.0125, we should get 1.1, and we need 3 sig figs, so 1.13 grams of H2C2O4. We notice here moles cancel out, and we're left with grams. So that's our answer. Okay, so let's do another problem. This one's asking for how many moles in our solution. So again, we have our equation, molarity is equal to moles over liters. So we would take that 0.15 mole, capital M is moles over liters, is equal to X over 11 liters. Liters cancel out, so we get 11 times 0.15 is equal to X is 1.65 moles. So these are pretty straightforward. Okay, so before we go over to molality, I'm going to pull up your worksheet and we're going to do one of the problems there. Okay, so this is your worksheet that's on Classroom. So I want to go over a couple different types of problems on here. So sometimes you're going to be asked to find the molarities. So important thing to remember is that your solute is going to be in your solution. So this is telling you that this is your solute. So we have to get this 30 grams into moles using our molar mass. So again, we're going from grams to moles. So remember, when we're going from grams to moles, we're going to be dividing. So when we're going towards moles, we're dividing. When we're going away from moles, we're multiplying. So here, we're going to have to find the molar mass from our periodic table. So you should have your periodic table out. So we have 1.008 plus 2 times 12.01 plus 3 times 1.008 plus 2 times 16. And this gives us 60.052 grams in 1 mole. You notice here that the grams cancel out, we're left with moles. So if we do 30 divided by that, say 30 divided by that gives us 0.4996 moles. So I'm just keeping a lot of sig figs. And then we're going to be dividing that by our liters of solution to get molality. Molarity. So we have molarity is equal to moles over liters. So we have to also get this to liters. So that's going to be 0.8 liters. So now we're going to take our moles, divide that by our 0.8 liters, and then we get 0.6 molar. So we can write that as capital M or 0.6 molar. Those are both correct. So that's where you ask to find the molarity. So again, just be careful about what's your solute, what's your solvent. So let's go down here and let's look at where you have to find the volume. So here we have to find the volume. So let's look at this one. So make sure you're writing your formulas correctly. So we have our equation, molarity is equal to moles over liters. So for us to find the volume, we're going to have to first get the moles. We don't have moles, we have grams. So we have 80 grams of sodium hydroxide. So we have to convert that into moles by dividing by our molar mass. So let's look at our periodic table. So we get sodium has a molar mass of 22.99 plus 16 plus 1.008, and that gives us a molar mass of about 39.998 grams per mole. So if we do 80 divided by that, we get 2 moles. And then if we plug that into our equation for molarity, so this is molarity, 2 moles over liters is equal to 2 moles over X, and that means X is 1 liter. Okay, so pretty straightforward. So that's how you do your molarity problem. So now let's go over molality. Okay, so let's go over molality now. Molality is lowercase m, and is sometimes called molal, and it's moles of solute over kilograms of solvent. Now, if we have water, This is going to be, we have to remember that 1 kilogram is equal to 1 liters, because sometimes we will be given liters of water. So we need to get that into kilograms before we can solve. So just an example of this, if we have 0.25 m, lowercase m, this will be 0.25 moles in 1 kilogram of solvent. Okay, so I want to work through a couple of problems. So how many moles of solute are in 600 grams of water? So here we have 0.21, and this is not meters, this is molality. So 2.1 molal. So this is, like I said, this is molal. That's how that's written. So we have 2.1 moles over kilograms is equal to X over, and then we have to get this into kilograms. So this will be 0.6 kilograms. So let's do that. So we see it's 2.1 times 0.6, and that gives us X is equal to 1.26 moles. For sig figs, that would be about 1 mole. So let's look at another one. Here we have what mass of barium chloride is needed to make 2.1 Molal solution with 750 milliliters of water. So here we have our equation, 2.5 molal, so that's moles over kilograms, is equal to, and then we have to remember that this is 0.75 liters, and if you remember, 1 liter is equal to 1 kilogram, so that's going to equal to 0.75 kilograms. So now we have X over 0.75 kilograms. So first we're going to have to solve for moles. So if we cross multiply, we get 2.5 times 0.75. That gives us X is equal to 1.875 moles. And now we can use our heart and get to mass of barium chloride. So remember, barium chloride is BaCl2. So we have 1.875 moles over 1. And then since we're going from moles to grams, we're going to multiply. So 1 mole in the denominator. And then we have barium chloride is 137.33 plus 2 times 35.453. And that gives us 208.236 grams. The moles cancel out. We multiply that by 1.875, and that gives us, thinking of sig figs, 390 grams of BaCl2. Okay, on this worksheet, you just have to be really careful about identifying the solute and solvent. So solute will be in the solvent. See here we have sodium acetate dissolved in water. So this means this is our solute and this is our solvent. And remember your equation, molarity is equal to moles. And this, remember, this is our solute. And then this is kilograms of our solvent. Okay, so what your solute is, you're going to have to get to moles or maybe get out of moles. And then your solvent, you're going to have to make sure is in kilograms. Okay, so that's what you need to be careful with this sheet. So just remember 1 kilogram for water, 1 kilogram is equal to 1 liter, to help you to go between grams and kilograms, and also if you're given liters, to get it into kilograms, to easily get it into that. Okay, so these problems are very similar to your molarity problems, so try these, see how you're doing, and see if you have any questions. Okay, so I want to show you this video just to show you now the difference between molarity and molality, because a lot of students confuse these two. So let me just play this. Okay, so what's happening here is this person's using rubber stoppers to represent moles. So he's going to prepare a 6-molar solution by adding that many rubber stoppers to the solution. So there he's added his solute, so 6 moles of his solute, and now he's going to add water and take it up to the 1 liter mark on this graduated cylinder to make 6 moles in 1 liter of solution. So he's carefully adding it, and then he's going to examine the meniscus and make sure he's at 1 liter. So that is a 6-molar solution. Now he's going to prepare a 6-molal solution. So here he has 1 kilogram of water, which he's adding to the graduated cylinder. So he's just adding 1 kilogram of water. That's his solvent. And then he's going to add to that the 6 moles of his solute. So again, he's going to take 6 of those rubber stoppers and add those to the solvent. So 1, 2, 3, 4, 5, and 6 moles. And what you will notice is that the 6-molal solution has more volume, a larger volume than the 6-molar solution. So the 6-molal solution will actually be a little bit less concentrated than the 6-molar solutions. That's the difference. So just so you don't confuse the two. The last type of concentration I want to go over is mass percentage. So when we're talking about mass percentage, this is something you'll see not so much in the lab, but you might see like when you buy acne medication or maybe some kind of prescription medication from the store. So here we have mass percent of A. A can either be your solute or sometimes it could be the solvent. So you have mass of A in the numerator times 100 over the total mass of the solution. So I want to work through a few different types of problems so you can see like how this looks in a problem. The first problem I want to show you is actually finding the mass percent of a solution. So here we have potassium nitrate. This is our solute, because you notice it's written in water, so this is our solvent. So we have our equation, mass percent is equal to mass of A over mass of our solution. Okay, so when it just says what is the mass percent of a solution, you can assume that A is going to be the solute, unless they tell you otherwise. So here we have 152 grams of potassium nitrate. And it's telling us this is in 7.86 liters of water. So remember, this is the mass of the solution. So first thing we will need to do, if you're not given grams of your solvent, is you need to convert this into grams. And remember, 1 liter is 1,000 milliliters, and 1 gram is equal to 1 milliliter for water, because water has a density close to 1. So here we know this is 7,860 grams, because this is 7,860 milliliters. So then in the denominator, we're going to have to add the mass of our solute plus the mass of our solvent. And then since this is a percentage, remember we have to multiply this by 100, our answer by 100. So you notice here that the grams will cancel out. So let's do that. We have 152 times 100 is equal to 152. It's over 152 plus 7,860. And that gives us about 1.90 mass percent. And sometimes mass percent will be written as W over W percent, or it might be written as M over M percent. So you'll see those written sometimes. So that's one type of problem where it asks you to find the mass percent. Let's do another type of problem where they ask you to figure out the mass of your solute. So I'm going to go to a different problem now. Okay, so this is another type of problem you'll see where you're given the mass percent and it's asking you to find the mass of acetic acid. And it tells you that you have 250 grams sample of vinegar. So vinegar is actually your solution. So we have again mass percent. And this is going to be of acetic acid. So A is acetic acid. This is our A. So this is equal to mass of A over mass of our solution times 100. So in this case, we have 5% is equal to mass of A. We don't know what mass of A is, so that's going to be our X over, and we know that we have 250 grams of our solution. And then, okay, so then we're going to do 5 divided by 100 times 250. And that gives us X is equal to 12.5 grams of acetic acid. So that's another type of problem. Now, one last thing I want to mention is sometimes they would ask you how much solvent is required. So in a problem like this that we just did, here we found that there's about 12.5 grams of acetic acid in 250 grams of vinegar. One thing you have to remember is that the mass we had of vinegar, this 250 grams of vinegar, is actually, this is the mass of our solvent plus our mass of our solute. This is our mass of our solute we just found. So to find the mass of water that would be necessary to produce 250 grams of solution, we would just subtract 12.5 from 250 if we were asked for that. So we do 250 grams minus 12.5 grams. And that would give us 237.5 grams of water. Okay, so that's just another spin on a problem if they were to ask you how much solvent were required. So just try some of these problems when you run into them on your sheet. Your sheet you're going to see is going to be a mix of molarity, molality, and mass percent. And see if you have any questions. And good luck.